Yeah, this is about the STAADPRO, Structure Analysis and Design Program version. It is a V8i 2008 interactive version. The STAADPRO workflow is as creating my new project file and creating the geometry model, defining the properties for your structural component, size, shape, which we call it a 3D modeling. And after that, we assign the required supports, constraints. We define the loads, we define load combination by auto manual, as we can, the STAADPRO have that option. You can generate your own load combination as per the requirement. After that, we do the structural analysis with the using STAADPRO and post-processing mode. We view the results. The results we require in a structure after structure analysis are bending moment, shear forces, reactions, and displacements. And we after that all getting all those result analysis result upon that for that forces we design the structural component, and by using the STAADPRO we can generate reports, design reports, and the design results in the form of drawings. So today I'm covering the two examples, design of reinforced concrete structure, a small example with a residential building G+1, and another example for a steel structure, a design of a steel truss. My voice is audible. Is it fine?
Yes, yes, audible,
Volume and
audible.
everything?
Everything okay. Fantastic.
Yeah. So I'm just moving right now the example of residential building ground plus first floor. The very initial step with the STAADPRO is to create a new project. We select the space, we select the units, and next we move on. And after that, we come into a space modeler of the STAADPRO, where we add the structural component being column, plates for the slabs and all, and we complete the 3D modeling. We can complete the 3D modeling by going the menu geometry, in which we can run a structure wizard, where you can have some predefined structure frame system, bay frame system, grid frame system, floor grids, some continuous beam, cylindrical frame, and many other two options. And about clicking one of the, as we want to create a residential building ground+1, I selected a B frame in which I had defined the total dimension of a building, how much is the length, what is the total height of my building, what is the width of my building, and a number of bays along the length, number of bays along the height, number of bays along the width. And according to those widths, base length, I can modify by clicking the sub button given over there. So this is how I completed the, created the geometry. And after that, I use the replicate, copy paste commands there, where you can replicate the stories to other stories, the members. You can define the rest of the stories too. So this is how we complete the geometry by using the different commands which we have in the STAADPRO. After that, once my model, the structure or beam column system, all the member I have modeled. After that, I define the section properties to those members, whether the material, also the material property, the dimensions, by going into the modeling part, into the general command, under which we have to define the section rectangular, or it is a trapezoidal, it is a circular. We define material to when we're defining the properties to the section, and we give the dimension to our section. If my beam is a rectangle, so I select the rectangle one, I give the dimension, and I need a slab components to define. So I use a property thickness in the same under the general tab with the define the section properties, and where I use the thickness, in which we can define a plate. We model a slab as a plate, and material it is to concrete, and I overall all the thicknesses have given a 0.15 as 150 mm is my slab thickness. This is what all the plate thicknesses I assign to whatever the plates I have drawn in the model. I would assign this property, section properties to all my plates by selecting that property and assign to selected place and then assign. This is what we do. This is the 3D rendering view of my model, what I have created after defining the properties, sectional properties. The next part is when your model is complete, we provide a support. As a building foundations, we give the fixed kind of support. So I define the fixed supports by under the general tab, you will find a support tab. And once you click the support tab, we'll define the support and selecting that support and selecting the node, those nodes where you want to assign that support. We assign to selected nodes and we assign the supports. Now, once we have completed model and suppose everything, we come to the defining the loads. Now we have to apply the loads to all the members. This is example of seismic definitions. We have to define the loads. When under the general tab, we have the loads and definition tab, under which once we click to this tab, we'll get this menu of load and definitions. Under this definition, we'll define the seismic definitions. Once we click this, select the seismic definition, after that we'll click the add. Once we add, it will pop up the another menu, seismic definition, where we select the seismic parameters by selecting the required code. The parameters we define, different self-weight, joint, mammal, all the dead loads, what is required to generate a seismic load. And we add that. And after that, once we the seismic definition, we'll selected the IS code, IS 1893, under which as this buildings is coming into a zone 5, we define all the zone parameters and the response reduction factor is if I'm designing this beam, this whole structure, ductile detailing is there to the component or not, or whether what is my structural system to resist the seismic loads. On that, we define the response reduction factor, which is called the R. There are different response reduction factor from 3 to 8 like this, and what kind of a frame system is there. According to that, we select this response reduction factor. This response reduction factor defines that we are actually depends upon what the framing system we are using. In this building, I'm using a special reinforced concrete moment resisting frame. I will follow all those criteria required specified as per the IS code 1893. So I'm using the respective reduction factors of 5 for that. And the importance factor, this is an ordinary residential building, so the importance factor is a 1. Soil type is a medium I've selected. Structure type, it is RC frame building. And you can also, we use, as this is a reinforced concrete, so we have for the concrete building, we have a damping ratio is a 0.5%. So we define the damping factor also. All this factor, once we define and we generate the seismic load, it will reflect all the parameters inside the box, and we add this parameter, so it will reflect in your seismic definitions like zone, what is my zone factor, what is my response reduction factor, what is my uh, damping ratio, what is my foundation depth I've considered, all this, and what are the weight I have included to generate this seismic and for the seismic loads. That is mostly self weight of all the concrete element will become, and also all the dead load, superimposed dead load coming inside a building also contribute to seismic load. So all these load we define under the seismic definition, and we assign these to the our model. Now we'll come to our normal loads. What we use are dead load, live load. So this is I define the dead load, live load, earthquake load. We define the load cases. Once we have defined all the special kind of wind definitions, earthquake definitions, we'll come to load cases. We'll define these load cases: dead load, live load, earthquake, and wind. What the load cases we required to analyze our structure. So this is what we add the self-weight under dead load. And once we add the self-weight, we'll select that self-weight and we'll assign to a whole model. So the self-weight get included in your dead load case. So after that, once we completed all the load definitions, we'll go to the load combinations. We can generate auto load combination by selecting the required code, and also we can make your own also. We both the options STAADPRO gives us. So once all the load combination has been defined, then we move to the analysis part, and we go to the command menu, under which we go to the analysis tab. Under that, we have a perform analysis. We'll click on perform analysis. After that, we'll go again analyze menu, and we'll click the run analysis. After that, it will start analyzing your building. After once it will show zero error or some warning, and after that, once it's done, we go to the post-processing mode. In the post-processing mode, we can view all the analysis results which we were interested for getting the bending moments, shear forces, displacements, all those components, each component, displacement, bending moment, shear forces, we can get the analysis result in post-processing tab. This is the bending moment diagram for the whole structure, and this is the result of slab what we created, the slab stresses. Now, once analysis has been done, we'll design our RCC components. So we'll move to the design tab, and under the design tab, we'll select the concrete, and under the concrete, we'll select the country code under which we'll be designing our all components. And after selecting the code, we'll select the parameters. For the concrete design, we need obviously compressive strength of a concrete. What is the steel yield strength of my steel, max main reinforcement and the secondary reinforcement? What will the minimum and maximum die of the bar I will use for the design? What is the main bar size? What will be the maximum main bar size, minimum main bar size? So the STAADPRO can use in while generating the design output. So all those parameters we will define. Once we have defined all the parameters, we'll give all like what is the compressive strength in the defined parameters by giving the compressive strength of a concrete, the grade of concrete for what we are using for designing of our building. Similarly, the strength of the steel what we are using, all this we will define in the defined parameter, and we'll add these all. These all will reflect under your concrete design menu. And once all this parameter has been defined, then we'll move to the command tab. Under the command tab, we'll give the commands to a STAADPRO to design beam, design column, design slab elements. Also, we are interested in the taking of the quantities. So we'll give also the command takeoff, where you can get the total volume of a concrete or each component volume, steel, weight. So once we define all the parameters command, we will assign these parameters and commands to our model. Here I selected all the columns, and I selected the command design column and assigned to selected beams and then assigned. So this command has been assigned to a vertical member. So the STAAD will design these beams as a column. So once all design commands has been given, parameters has been defined, we again perform the analysis from command menu. Similarly, when we perform during the analysis, and under the analyze tab, we will run analysis. So the STAADPRO will perform a design, concrete design. This is the and again we'll go to the post-processing tab, where you can view under the beam tab, we can select one of the beam, and then it will display the And based upon the parameter you've given, it will display the design, concrete design. Also, it will display a property, loading, shear, bending, deflection, all this under the different tabs. This is the concrete design of a beam as a column, as we have given this command for this vertical beam as a column design. So it has designed this beam as a column. And obviously under the report tab, if you click, you'll get the report of all the elements, whether it is passing or failing, what is the concrete, what are the bending moment, axial forces or tension forces, whatever the member is carrying, it will display under the results. I'll move to my second example, that is analysis and design of a steel truss by using a STAADPRO. This is a simple truss. It is carrying a 3-point loads as displayed at 3 nodes, and having a 1 fixed and 1 hinge support. And these are the dimension 2.4 meter 2.4 meter spans, and the vertical span is 3.6 meter for this truss. So similar, we will create a new project file where we'll define, we'll select the truss, we'll give the file name, we'll select the units. Obviously, units are very, very important. The meter, kilonewton, the forces, all it will display in the kilonewton, and the dimensions, length, and other parameter it will display in the meter. We'll select the next. And it will come to your geometry part, modeling part will come to defining the grid systems, and where we can select the grid spacing and all. Under that grid spacing, you'll model your whole truss. After that, once I model my truss, I'll apply supports. I'll define the supports and apply them. So now I have to assign the member properties. I'll select all this truss element, and I'll select the Indian under property tab. I'll select the code Indian, under which I'll use angles, and under that I'll select angle from the given database. There is already a database. As per this code you select, you can select that angles, and with that properties, with the dimensions, you can assign to your truss components. So all the I've selected all the members, and I select the section property and assign the same section property to all the members. You can have one or more also steel sections as per the requirement, and you can assign a different section to a different member of your different size of angle to the different member. Here I'm using a simple one only, and I'll check whether it is passing or not. If it's not passing, I'll change. I'll define another section, and then again assign that section property to the fail member. So right now I'm applying a single one section and applying it to all the members right now. And I selected that section, and then I selected all this steel component of truss, and assigned this section property to all those components. And once I've defined the properties, section properties, everything to the truss components, now I'll go to the load definition, where I have to assign the loads, the given loads, the point load. Here I'll go for load case details, under which I'll add this loads under dead load. Obviously I'll apply a self weight, so self weight of the member to take into the analysis. And once I define the self weight, I'll create the node loads. I'll under the tab dead load, I'll select, and I'll add it. And again, once I add it, will add a new load pattern. It will come item, and under which I'll select the nodal load, under which I'll give a load of 8 kilonewton minus, because it's directing downward. So 8 kilonewton minus 8 kilonewton, I'll apply. I will add this, and I'll select that self weight, and those self weight, I'll apply this self weight to the assigned to view. So the self weight shall be considered in the analysis. And After that, once I define the nodal load of -8 kilonewton, I'll select that load and I'll select those nodes where I want to apply that load. And then I'll apply the selected load to assign this under assign to selected node. By selecting this option, assign to selected node and assign this load. So you under this load tab, you can view that the load what you have assigned has been assigned to the required nodes. And once all the loading has done, I'll perform the analysis. From the command menu, I'll go to analysis, perform analysis, and after that, I'll go to the analyze menu, and under which I will run analysis. So once the analysis run, it will display that all the analysis has been done, and there is no error, no warnings, and no notes, and we can go to processing mode and done to view the results. So once the analysis is done under the post-processing tab, we can view the results, deflection, moments, shear forces, axial stresses, tension, compression coming in the members. Also the reaction at the supports under the reaction tab. So once analysis has been done, I'll move to a design part where I'll select the under the modeling, I'll click the design tab, and once I click the design tab, you come to the steel design whole structure will come, where I'll select the required code as per the Indian code IS 800 I'll use, and under that, I'll select the parameters what are required to design the steel. Of course, the yield strength of the steel, the grade of steel I'm using. After that, I'll define the yield strength of the taken steel under define parameter. I'll define and I'll add that parameter. And once I add it, I have to assign that parameter to my model for designing purpose. And once I have then, once all the selected parameters and define those parameters, I'll move to a command prompt. I'll click the commands and where I'll give the commands to design the steel design to the STAADPRO. Where I'll use the check code, I'll give the, I'll also add the member takeoff, select and takeoff. All these commands I'll add for the design. So you'll view all those added command and I'll select one by one this command and assign to my model by selecting assign to view. So all the commands has been assigned to your model. Then we'll move to a analysis again. We'll run analysis from the command menu under analysis. We'll perform the analysis. After that, we'll again run the analysis from run analysis wizard, and we'll see the output. There's no 0 and 0 warnings. And we'll see the result under the result tab. You can have a report under which all the commands of the design has been taken by the STAAD, and he has generated a report for all those commands where you can find all design of your steel components. Once I click one of the member in the one of member of my truss and right click, it will display your result, whether it is passing or fail. You can see the what are the deflection in that member, what is the shear bending, all those results, and what is my ratio is coming, and whether member is passing or failing. You can view by right click on that member. So this is how we finish our steel design, and we can check each component. So this is all about the STAADPRO. Yeah, so I finished with this STAADPRO presentation.
Okay, and any other like ETABS or SAP?
Actually, I don't have the software with me, so I was not able to make. But I have a safe with me, but it's also not running. But small file I have, I can display the file. The similar way we can make design example is very short one, but once a student, we have to also show them a manual calculation and the same calculations and result performed through the STAADPRO.
Sorry, Rubina, it was nice presentation.
Yeah.
Only thing is like, what I expect because we are going to conduct seminar for the students also, maybe those who would like to enroll either online or offline. Okay.
Mm-hmm.
So maybe
Mm-hmm.
this Sunday we'll conduct online only, and thereafter coming Saturday you can come for offline also, and let's see. Because once it start, your training activities get started, so offline and online both possibilities
Yes,
comes up.
this I just made to, just for you to how I'm speaking, how I'm displaying.
Okay,
Uh,
okay.